Today, we're diving into Delhi's really complex and, honestly, super creative fight for clean air. We're going to go from this massive region-wide forecasting system all the way down to a single dusty road to see how the solution might just lie in changing one person's mind. So to really get what's at stake here, let's just start with this one number, 1.4%. According to the World Bank, that is the slice of India's GDP that's just gone, lost to illnesses caused by air pollution. That's an absolutely staggering cost, not just to people's health, but to the entire economy. And the heart of this crisis is so often felt in Delhi. I'm sure many of us remember the headlines back in November 2016 when the city was just choked by its worst smog in 17 years. I mean, at its peak, the most dangerous stuff, PM 2.5, hit levels 14 times higher than the national safety standard. This isn't some far-off problem, it's a full-blown public health emergency. And look, while Delhi might grab the headlines, this is a nationwide issue. It's huge. In fact, research shows that about 70% of India's entire population is breathing dangerously polluted air. So you can see why the search for solutions in Delhi is so critical. It's really a test case for the rest of the country. So how in the world do you fight an invisible enemy? Well, Delhi has made a big shift, from just reacting to pollution events to proactively trying to predict them. You should think of it like a weather forecast, but for air quality. The whole idea is to see the smog coming days in advance so that authorities can act before the crisis actually hits. The system really has two core parts that hit together. First up is the AQEWS, the Air Quality Early Warning System. That's the forecast itself, predicting what the pollution levels are going to be. Then, based on that forecast, the GRAP, or Graded Response Action Plan, kicks in. This is basically a preset playbook of emergency measures that get triggered automatically. They really work hand in hand. One predicts, the other acts. Simple as that. Now, this is where it gets really cool. Just look at the level of detail we're talking about here. This is the Decision Support System, or DSS dashboard. It doesn't just give you a vague pollution will be bad tomorrow. No, it breaks it down, forecasting exactly how much pollution is going to come from 29 different sectors. We're talking transport, industry, construction, and even from 20 surrounding districts. It gives officials this incredible, almost forensic understanding of where the problem is coming from. Okay, so how is all this info actually used? Well, it's through the GRAP plan's 4 escalating stages. Stage I, might just involve some simple dust control measures. But as that forecast gets worse and worse, much stricter actions get triggered, like banning all construction or even restricting vehicles on the road. It's pretty simple. The worse the production, the tougher the response. Now, this all sounds pretty impressive in theory, right? But it begs the big question. How accurate is this high-tech crystal ball really? Can you actually predict something as complicated as air pollution reliably enough to shut down huge parts of a megacity's economy? Well, let's look at the data, specifically for the most dangerous, severe pollution days. In one recent winter season, the system predicted just 1 out of 15 of these episodes. That's an accuracy of only 7%. But then, the very next year, that number jumped to 5 out of 14, which is 36% accuracy. That's a massive improvement, and it shows the system is actually learning and getting better at pinpointing those worst of the worst days. So here's the big picture. The system is actually really good. We're talking over 80% accurate at predicting those very poor air quality days. But its biggest weakness is what they call consistent underprediction. Basically, it often fails to see the absolute worst days coming. It's like it's hitting the outer rings of the target every time, but it's still missing the bullseye. All right, so now we're going to zoom in a bit, because while we all tend to think of traffic and industry as the main villains, the forecasting data points to another huge contributor that kind of hides in plain sight: dust. Specifically, dust from the city's booming construction sector. This chart really tells the story. It breaks down where all that particulate pollution in Delhi comes from. Okay, transport, biggest slice at 28%. No surprise there. But look at the second biggest piece of the pie. Dust from roads, soil, and construction comes in at a massive 17%. That is a huge chunk and a major target for those GRAP action plans we talked about. So what do you do about all this dust pollution? Well, often the solution is a very blunt instrument. Just ban all construction. And in just 2 years, authorities imposed a staggering 73 days of complete construction shutdowns. That's more than 2 full months of lost work for an entire industry. And that has a massive human cost. These bans directly hit the livelihoods of nearly 10 lakh, that's 1 million, daily wage workers in Delhi. A simple shutdown might clear the air for a little while, but it creates this enormous economic hardship. And this reality is forcing experts to ask a really important question. Isn't there a better, more nuanced way to do this? And that question brings us to this absolutely fascinating pilot study that asks something totally different. Instead of a top-down ban, what if you could change behavior from the bottom up? What if you could actually change people's minds to clear the air? The study used a framework from behavioral science called the CALM-B model, and it's a really simple but powerful idea. It says that for any behavior to happen, a person needs 3 things. First, the capability to do it. Do they know how? Second, the opportunity to do it. Can they actually do it in their environment? And finally, the motivation to do it. Do they even want to? You need all 3, or it just doesn't happen. So, the researchers targeted one very specific behavior that's known to kick up huge amounts of dust: heavy-duty trucks driving way too fast on a 100-meter unpaved road at a construction site. The goal was dead simple: just get the drivers to slow down. The results were, wow, just remarkable. After some simple behavioral nudges, not only was there less dust in the air, but the dust itself became less dangerous. The key finding is right here. The ratio of those really fine, harmful PM 2.5 particles to the coarser ones fell from 0.6 down to 0.4. So, in other words, just slowing down the trucks changed the very makeup of the dust, making it less of a threat to human health. And what's crucial is that these results were statistically significant. This wasn't just a fluke. It proved that a low-cost, worker-led approach, one that focuses on changing behavior instead of just imposing bans, can have a direct, measurable impact on air quality right at the source. Okay, so let's zoom back out. What we're really seeing here is the beginning of a powerful 2-pronged strategy, pairing these massive, high-tech forecasting systems with these small-scale, totally human-centric solutions. The research really points to a clear path forward. First, you've got to improve the big-picture systems with better, regularly updated data. Second, allow officials to actually model the impact of their actions before they take them. Third, and this is the big one, scale up these low-cost behavioral interventions. And finally, get better at accounting for all the pollution that's just blowing in from neighboring regions. Ultimately, what this whole journey, from the satellite forecast all the way down to that dusty road, tells us is that the fight for clean air is evolving. It's not just a technological problem that we can solve with better sensors and fancier models. It's also a human problem, and it's rooted in the thousands of individual choices that get made every single day. Which really leaves us with this one final thought. The scale of air pollution can feel so overwhelming, right? Like it's a problem that's just too big for any one person to solve. But as these experiments in Delhi show us, from the high-tech control room to the construction site, maybe the most powerful tool we have is the ability to change our own behavior. The real question is, can we do it at scale? Thanks so much for joining us for this explainer.